Alright, it's me, recording lesson 10 of the beginner programming series for the second time. Okay, let's do this shit. Last time, I think we had something that looked a little bit like this, and if we run it, it does this. Makes a line, right? And then I told you guys, okay, that was easy. Now make this. So how do we go about making a making a rectangle there? Well, if you look at a line, what is a line? It's just a bunch of pixels laid side by side, right? And how we made our line is we looped through a bunch of put pixel calls so that we could lay our pixels side by side. Well, so what is a rectangle? It's just a bunch of lines laid side by side. So if we had to make a line, we had to loop through a bunch of put pixels to put pixels side by side. So it stands to reason that to make a rectangle, we have to loop through a bunch of line drawing code. And that's what we're doing here. So we do int y equals, 100, while y is less than, we'll do this proper here. Okay, if I make it 100 by 100, and it's 300, that's 200. No, that's 250. Okay, where's my delete key? There it is. So we got 250, and while y is less than 350, I hate you, keyboard. We wanna do another loop. So we put our line drawing loop inside of another loop. So now we're drawing lots of lines. Okay, so x will be from 350 to 450. And after the end of this loop here, we have to increment our y. And I mean, that should do it. That should just about, oh, wait. I almost forgot. I gotta set now we're looping through x and y, so we need to set this to x and y here. And if we do that, success. Alright. Now, to make it move around the screen and to be able to resize it, what you need to do is you need to create variables to remember the x and y position. It's not going to work. Yeah, I can't name it. It's not a good idea to name this x and y because our loop variables are x and y, so that would be stupid. We'll name this box x and box y and box width, box height. There we go. So now we have our loop variables, and what we do here is, let me see. Well, we're going to say y is equal to box y. And as long as y is less than box y plus box width. No! So instead of hard coding these constants in here, we make these numbers variables that depend on, well, basically in the end it'll depend on what buttons we're pressing on the keyboard, right? Okay, so x is box X, and here we have again box X plus box width. And then we have to go here and initialize our box variables, and then we have to go down here and write the keyboard code. So if keyboard dot blah 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 blah, and if we do all that crap, then the end result should be something like this, right? I'm not even going to do it. You know what? You guys can figure that out. I mean, if you're really having problems with it, you can ask on the forum, but honestly, that's just a simple implementation detail. We've done moving and shit like that before with the cursor stuff, so it shouldn't be hard for you to initialize the variables here and then use the keyboard input to modify the box variables. So I'm not going to show that because we're busy. We got a lot of stuff to cover today. So the other thing I gave you guys was this, right? Just making a design in by changing the color variables here, or the color values. I keep opening the wrong thing. Yeah, so right now it's just hard coded to 255, but if you make these color component values, if you make them vary depending on X and Y, you can get designs like this. Okay, there we go. I'm not going to explain that here. That was kind of a bonus, but I will put a post in the forum showing how I did this eventually. I'll give you guys the code and a brief explanation about the mathematics behind it. But it's not a big deal. It's not a main part of what I'm trying to teach here. Just a little fun exercise for any of you guys who found the rectangle exercise too trivial. But it's over now. It's finished. It's time to move on. So, before I get started, I just want to show you guys. Again, I put this on the forum, but only a few of you have downloaded it, so I'll show you here in the main videos. This is what we're working towards. I think we will make this game in episode or lesson 12. So, yeah. This is what we're looking forward to. So lesson 11 and lesson 10, this lesson, and lesson 11 will just be we'll learn some basic skills that we're going to need when we will make this game. So today, first thing I want to show you guys. So last time we learned the while loop, and it was good. It is good, as you can see, but there's another loop, or another form of loop here, that I want to show you guys. And it is actually more common. So I'm going to show it to you. Put this like this, and yeah, that's good. It's called the for loop. And it's basically the same thing as a while, except it's got some extra bells and whistles. So that compiles fine, and if I run it, build, no, I said run, there. Oh, access violation. Well, that's not good. I'm gonna break. X, Y. Oh, right, okay. Yeah, that was stupid. I have it on box X, box Y, but I haven't actually initialized those variables or done anything with them. So, yeah, that would be a problem. Okay, cocksucker. You can go back now to being the way you were before. I did a bunch of crap. So you can see the variable initialization and the incrementing all goes inside of the for statement here. So while the while loop only has the loop condition, The for loop gives us three different sections here. The first one allows us to initialize a loop variable. The second section is the exact same as the while loop. It's just the loop condition. And in the third section, we can increment our loop variable. So what happens is the first time you enter the for loop, it does this. Then it checks the condition, and if it's true, it executes the code block. And finally, it executes the increment operation, or whatever, the variable updating operation. And then it goes back here and checks, executes, updates, checks, executes, updates, until this is false, and then it exits. So functionally, it's identical to the while loop. It's just, I don't know, it's a more compact way of writing things. So you can use either one, it doesn't matter, but I'm going to be using for loops quite often. And in other code that you will see, you will definitely see the for loop over and over again, especially in cases like this where we have some kind of a variable that we're incrementing, and that variable is controlling the execution of the loop. In those cases, you almost always see it done as a for loop. Some cases are for while, some are for. It's just mostly a matter of preference and convention. And as we go along, you'll get a general idea of when programmers use each of these types of loops. But like I said, they're both functionally equivalent. You can use either one. It doesn't matter. Okay, so that's the for loop, and we'll be seeing a lot more of this guy. So no need to go into super heavy detail right now. We'll get plenty of practice with the for loop. Rest assured. I'm gonna get rid of this crap. Okay, so today what we're going to be doing is we're going to be drawing a straight line. Alright, so here is our straight line that we had before. And I mean, it works great, right? Start debugging. We got our horizontal line. It's very easy. We just loop through x's. If we wanted to make a vertical line, we could do something like this. Say y is equal to 100 to 300. I don't know. And then we'd go. We'll set x to 400, and y will be our loop variable, and we want to do y plus plus here. And there we go, we got a vertical line, right? That's not too hard. And just to show you, we can also make a diagonal line 45 degrees. If we use our loop variable twice here, we'll get something like this. Going like that, right? That's fine. But now let me ask you this question. What if we want to make a line that's not quite 45 degrees, that's like 30 degrees or something? Just a line. Basically what we want to be able to do is make a line between any two arbitrary points on the screen. And in that case, a simple loop like this is not going to cut the mustard. We're gonna need to think about this one, and we're gonna need to use some math. Dun dun dun. Mathematics. Geometry, my friends. Linear equations. So, it's time to learn. It's time to get us some book learning. This is our y-axis. So, this represents the y value, or the y position. And this is our x-axis. You'll notice that this is different than when we're doing on the screen, because on the screen, y goes down this way, right? So it's x in this direction, y in this direction. But when we talk about geometry in Cartesian coordinates, just in normal mathematics, we orient our axes this way. So that's what I'm going to be using for this lesson. It's the same stuff. It's just on the video screen it'll be flipped down, right? Flipped down this way, but it's all the same. So you might as well get used to seeing it like this, because when you go online and when you look for tutorials about geometry and stuff like that, you're going to see it like this. So get used to it. And if you want to do 3D graphics, you're definitely going to be you're going to have to learn quite a bit about geometry. So now, here's the situation. We've got 2 points here, P1 and P2. I'm just going to make a new layer. I don't trust this layer. I'm putting it over here. Okay. So we got 2 points, P1 and P2. And what we want to do is we want to draw a line between these 2 points, straighter than this line. We want to plot the line in our program. Undo that. Now it's easy for us to do it as humans. We just, get out our ruler or whatever and we draw that bitch. But computers don't have, there's no rulers in there. They've got to compute things. So how does a computer draw a line like this? Well, you might be surprised to learn that we use loops. Yeah, big spoiler. Specifically, what we're going to do is we are going to loop through our x values from x1 to x2. So x1 here is at x equals 2, right? And x2 is at x equals, 2, 3, 4, 5, 6, 7, 8. So we're going to loop from 2 to 8. And for every one of these x values, we have to calculate. Let me think here. Yeah, bro. Here we go. We have to calculate what the corresponding y should be. So we go for every one of these x's, we calculate our y. This x, we calculate a y. Yeah. And yeah, sure. Calculate a y. And that will give us our y positions. And then for every one of these x's, we find the y. And then we put a pixel at that xy. This one would be here, this one would be here, 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 and here. Something like that. Maybe. I probably kind of fucked it up a bit, but whatever. So the question is, let me just undo all this crap because I want to. It's not letting me undo that one. Oh, okay, there we go. The question is how to calculate the corresponding y for every x. And the way we do that is we use the line equation. So we have y is equal to some function of x. This is the general form for plotting any kind of equation, right? So if we wanted to plot, say, a parabola or something like this, that's a really crazy parabola. Yeah, you know, one of these dudes. We'd still use a y is equal to f of x and stuff like that. For a straight line, our f of x is equal to mx plus b. So we can simply write that as y is equal to mx plus b. Okay? This is the equation of a straight line. So here's our... Whoa, that's... Yeah, pretend that's a straight line, right? This is the equation for that line. It represents a relationship between the x values and the y values. So when x is here, y is here, and when x is here, y is here. It tells us the relationship between y and x for every point on this line. And different lines will have different values of m and b. So the values of m and b, they characterize the line. Now I'm going to show you guys something. Fire up my trusty web browser here. And we're going to go to, this is like way off the screen. I should have resized this. There we go. Okay, so we're going to go to y equals mx. Oh, I already searched for this, so that's good. We're going to get a nice trusty Java applet going here. All right. So here you can see we've got a straight line here. The form of the equation is y equals mx plus b. So this is our value of m. This is our value of b. Now m represents the slope of our line. So if we increase our m, our line gets steeper. And if we decrease our m, our line gets shallower, right? And if we set our m to 0, our line is horizontal. And if we set our m to negative values, then our line is sloping downwards. So positive values slope upwards, negative slope downwards. And small values give us a shallow slope. I think that's what the word you would use. I don't know. Gradual slope, maybe. I don't know. And large values give you steep slopes. Large negative value will give you a steep slope going downwards. So the value of m represents the slope of the line. The value of b represents what we call the y-intercept here. See, we see slope, y-intercept. This is the point at which the line intercepts the y-axis. Or in other words, when x is equal to 0, y will be equal to b. So if we change this value, we can slide our line up and down. This one lets us tilt our line or rotate it, or whatever you want to say. And this one lets us slide it. So yeah, that's what these values actually represent for our drunken straight line here. But mx plus b. Okay. The problem is that we don't know m and b. We don't get that value. All we get is p1 and p2. So we get an x1 and a y1 and an x2 and a y2. And from those values, we have to calculate our m and our b. And once we know our m and our b, we can put values into x and get back a y value. So, how do we calculate m and b? Well, m, the slope m, the easiest way to remember m is rise over run. So, take any 2 points on the line. We'll take P1 and P2 because we know their values. And M is equal to rise over run is equal to, so this is the rise here. To go from P1 to P2, we have to rise this much, and then we run this much. So the rise is this distance here, the distance between y2 and y1. So rise is equal to y2 minus y1. And run is equal to x2 minus x1. Now because we are drawing our line based on P1 and P2, we know all these values. So we can calculate our m from our known values. And that's 1 down. Now how we calculate b is we use a little algebra. We know m, and we know at least 2 pairs of x and y. We know p1 and p2. So that means to calculate b, we just say, well, we subtract mx from both sides, and we say b is equal to y minus mx. Okay? And for m, we just take this calculated value and plug it in here. And then we say, okay, well, for example, we could use our y1 and our x1 in here and here, and that will give us our b value. And once we have our m and our b, then we loop through these x's, 2, 3, 4, 5, 6, 7, 8, and plug them into here and calculate this to get our y's. So for 2, we would calculate that, get our y, and then plot it here. And then for 3, we'd plug 3 into here, multiply it by m, add b, there's our y value, and then plot a pixel at 3y, whatever y is. It looks like it should be 2.66 something, maybe? I don't know. So that's the basically how you determine the equation for the line based on 2 points. Now I'm just gonna demonstrate the procedure for this case here. So there we go. Let's get rid of that nasty stuff there. Okay. So this is how we would actually do it. And this is how we're going to do it in our program. So we get our 2 points here. P1 is 2, 2, right? And P2 is, let's see here, that's 8. And 1, 2, 3, 4, 5, 6. 8, 6. And we want to draw a line segment between these 2 lines. So the first thing we do is we calculate our slope, m, is equal to x2, no wait, rise over run. So equal to y2 minus y1. y2 is 6 minus 2 divided by 8 x2 minus 2. That's equal to 4 over 6 is equal to about 0.667-ish, right? 2/3, okay? That's our slope. To calculate our b value, I deleted it, right? It's b is equal to y minus mx. So b is equal to, so we'll pick one of our y's. It doesn't matter which one you use. We'll use this one. 2 minus 0.667 times x, which is, again, 2. Let me think here. 2/3 times 2 is 4/3. That's 1.33. That's good. Okay. So 2 minus 1.333. So b is equal to 0.667. Okay. That's interesting. So our slope and our intercept are actually equal to the same thing. Yeah, that makes sense. That would put our intercept right about here. It seems pretty good. Okay, so now we have our M and we have our B, which coincidentally happen to be the same thing. They generally won't be the same. Now we can actually draw our line, or plot our pixels. So we're going to loop through our x values from x1 to x2. So for x1, we go y is equal to 0.667 times 2 plus 0.667. And the answer to that is, of course, 2. We just have to, we can look at it. We already have that point, right? And so then we put a pixel at 2, 2. Next one, we go y equals 0.667 times, this time we're at 3, so times 3 plus 0.667. And the answer is, I'm going to get my calculator out. Alright, let's do this. 0.667 times 3 plus 0.667 equals 2.668. So about, it's 2 2/3, right? Why are you getting all funky on me, you stupid thing? Yeah, you do that. So for this one, we have 2 2/3. So we'd want to put our pixel here. But you know, you can't plot a pixel at position 2/3. So we'll round it to the nearest pixel, which is 3. Yeah, whatever. Here. Okay? I'm not going to write all the other ones down. I'm just going to put them on the calculator here. Clear. Clear, bro. So the next one will be x equals 4. So we do 0.667 times 4 plus 0.667, and we get 3 1/3. Alright. Bro, you are really seriously pissing me off. Get down here now. Good. Okay, now I can do that. Awesome. Okay. So that means 4. So 3 1/3 is right around here, but again, rounding to the nearest pixel, we'd put our pixel here. And now I'm going to go for 5. So 0.667. No. Suck it. There. 4. So we put our y here. And next one is going to be here. So we'll put it here. That seems wrong. Why does that seem wrong? 4. Okay. 1, 2, 3, 4, 5, 6. 0.667 times 6. Alright. My bad. So x is equal to 6 should give us 4.666 ish, which rounded up will be 5. Alright. And now x equals 7. .667 times 7 plus 0.667 is equal to 5.33, which will round down to just 5. Right. Okay, this looks much better. And this is what our line will actually look like on the screen, right? If we imagine these as being pixels. Oi, the ugliest pixels you ever seen. Right, this is how our algorithm would actually draw the line on the screen. Yeah, and this just shows why we get the computer to do the calculations. Even these simple ones, I managed to screw it up somehow. I don't know, I pressed the button wrong or something. But anyways, yeah. So this is how we will calculate our y values, and then plot our points on our line. So now we just need to write the code for it. First things first. This is a very a general kind of graphics routine that will be useful basically anywhere. So instead of putting it in the game object, which is specific to one game, we are going to put this routine in the graphics object, because it's a general graphics routine. So you should go into your d3dgraphics.h and go void draw line. Int x1, int y1, int x2, int y2. Alright, and then we'll go graphics.cpp, void d3dgraphics, no, draw line, x1, y1, int x2, int y2. Alright. So we're going to make our drawLine function a member of graphics. Now, I said that we want to, we're going to loop through our x from x1 to x2. So that means we need a for loop. For int x. Now don't get x mixed up with our x1 and x2. x1 and x2 are just the values of our starting and ending pixels, whereas x is our loop variable that will be changing as we loop and traverse our line. So x, we initialize our x to x1, and then we say as long as x is less than or equal to, because we don't want to run up to x2 and stop. We want to run up to and including x2, right? So we have to go x is less than or equal to x2, and we increment our x. Now in here we're going to be doing a put pixel, and notice I don't have to put I don't put, before we always put graphics.putPixel, but here we're not doing that. And can you see why? It's a good question for you. So we want to put our pixel, we're going to put it at an x, y, 255, 255, 255. Actually, yeah. Int r, int g, int b. This function has a lot of parameters. R, G. So we'll make our function so that we can specify the color when we call it. It's not hardwired to white. It'd be more flexible that way, more dynamic. Okay, so this is basically what we want to do, but we need to calculate y. Int y is equal to what? Well, it's equal to m times x plus b. We need our m and we need our b. So let's calculate m and b. First, int dx. x2 minus, no, minus x1. That's just, where is it? Here we go. Oh, I hate you, Photoshop. I hate you with a passion. Thanks for doing that with my window. You bag of dicks. Okay. What was I talking? Oh yeah. So dy is just this distance. Dx is this distance. Yeah. So dx is equal to x2 minus x1. Dy is equal to y2 minus y1. And m is equal to dy, that's the rise, over dx, the run. And b is equal to, I believe it was y1 minus m times x1. So here we calculate our m and our b. And then we say y is equal to mx plus b. And we loop through values of x from x1 to x2. So this is just exactly what I showed you guys manually on the graph paper there. So let's see if I messed something up here. Yep, I knew I did it. Okay, what's the problem? Okay, yeah, I changed the definition of draw line. I added RGB here, but I didn't add it here. I always do that. Okay, this should work. Yeah, it worked. No, it didn't work. Redefinition of formal parameter b. Okay. So I have a b here, but then I try to define another b down here. That's stupid. So I'm going to call this one BL for blue. Okay, now finally it worked. All right. So let's test out our drawLine function. So because we made it a member of our graphics object, we have to access it through the graphics object. So we go graphics.drawLine. We'll do something simple. We'll draw a line from 100, 100 to 400, 100. Just a simple horizontal line. All right. Very good. And we'll start debugging. And there we go. Here's a horizontal line. So far, so good. Let's try a vertical line here. So we'll go from 100, 100 to 100, 400. Oh, okay. Integer division by 0. Vertical line is not good. It causes our program to crash. That's not good. So for some reason, vertical lines are not good times. Okay. Let's try a diagonal line, 45 degrees. 100, 100 to 400, 400. That works. All right. Let's try a diagonal line, but of an intermediate slope. Not horizontal, not 45 degrees, but halfway between. So that would be 200 here. And we get a horizontal line. That is definitely not the correct output. Okay, so something is wrong. If we try a vertical line, our program crashes. If we try a line with a gradual slope, we get a horizontal line instead. So we got definite problems here. Let's see what they are. What we're going to do is we're going to go into debug configuration, And let's go to our graphics thing. We're going to set a breakpoint at the beginning of our drawLine function. And we're going to start. We're going to run it. So we've just broken execution. This takes up too much space. Here. Let's step through the execution of our drawLine function and see exactly where it goes wrong. So calculate dx. Dx is 300. That's correct. dy, where is it? dy is 100, and that's correct too. So our line should go over by 300 and down by 100. Is that correct? Let's look at our game. Yeah, so horizontally it goes from 100 to 400. That's a 300 difference. And vertically it goes from 100 to 200. So that's only 100 difference. Alright. So our slope should be something like 1/3 or 0.33. Let's see what we get. So m equals 0. That's definitely not correct. And of course, if our slope is equal to 0, no wonder we're getting a horizontal line, right? I mean, set the slope here equal to 0. You get a horizontal line. So we have a problem in our calculation here. What is the problem? Why is it giving us 0? The answer is we've defined our dx and our dy as integers, and m is an integer. Integers can only take on certain values. Let's get rid of that. So your integer, you can have a value of 2, 1, 0, -2. You can have a value of 2 billion. But you cannot have a value of 1.5 or 0.033. Or in other words, you cannot have a fractional or decimal component. Integers are whole numbers only. And when you divide two integers, the result is going to be a whole number. So here we're dividing 100 by 300. So the result is 0 remainder 100, right? Or just in integer math, just 0. Let's get this back here, right? 100 divided by 300 equals 0, buddy, in integer mathematics. So if we had something like 400 divided by 300, the answer would be 1, because 300 goes into 400 once. So it'd be 1 remainder 100. This is 0 remainder 100. So our result is 0 and 1 here and here if we are using integers. And of course, m is an integer, so it can only store a value, a whole number value. That's another problem. The solution to this problem is, first, we have to make m something what we call a float. A floating point value is another type of variable. It's like an integer. It stores numbers, but the numbers it stores can be represented with decimals. So with a floating point, you can have 1.333 or 0.33333 something, whatever. That's perfectly fine. That's what floating points are there for. But this is not enough, by itself because dy and dx are still integers. So if you divide dy by dx, the result will be an integer division and you'll still get 0. Let me show you. Run again here. So what this will do is see, we get m is equal to 0.000000. So what this will do is this divides the integer dy by the integer dx using integer division, and the result is an integer, which is then converted to a floating point value and stored in m. So this still isn't good enough. The way we're going to do this is, let me just get out of the debugger here. If we type a type name here, a variable type, inside of brackets, and we type that before a variable name, what we're doing is we're saying, okay, computer, first convert dy to a floating point number, then convert dx to a floating point number, then divide those two floating point numbers by each other and store the value in m. So because we've converted the values to floating point numbers, the result will be, or the operation will be a floating point division, which will give us a fractional part, and the result of that operation will be stored in the floating point variable m. Now this doesn't change dy or dx, they're still integers, but what it does is it takes the values stored in there, converts them to floats, and then divides those values. dy and dx remain untouched, just so you know. Alright, so if we do it this way, and we step, step, and step, now m is equal to 0.33333333, whatever. Alright, and that's what we want. Now b also has to be, no, that's too big. B also has to be a floating point, right? And for b, we don't have to type like float whatever here. It's not necessary because this value here, we have a floating point value times a integer. So if you have a mixed operation between a floating point value and an integer, what the compiler does is it'll first it'll convert this value, the integer value, into a floating point value, and then it'll do a floating point operation. So if you have a mixed operation between floats and ints, it converts the ints to floats first and then does the operation. So this is the exact same. Wait. Damn it! Is the exact same as this here. No difference. So I mean, you could type it in if you wanted, but you don't need to. But you do need to make b and a floating point value, because if you leave it as an integer, it will do a floating point operation here, a floating point operation here, and then it will convert it to an integer and store it in here, if b is an integer. So we need b to be a floating point value. And then we do this. And this is, again, floating point operation between a float and an int. And then this result will be a float, and so it'll be between a float and a float. And finally, it will convert that float back to an integer here, and then we'll do our put pixel. So now, if I do this, now we get our line, and it is of the correct slope. It's not 45 degrees. It's somewhere in between there. 30 degrees? Yeah, it sounds about right. Or no. I don't know. Whatever that is. So yeah. Now what I'm going to do is I'm going to make it so I can control this from the keyboard. So wait a second, we'll be right back. Alright, so what I did here was I created variable x and y in the game object. I initialized them to 500, 300. And here what I'm doing is I'm drawing a line from 400, 300, which is the center of the screen, to x and y. And I can change my x and y by using the keyboard. See if I get any errors here. Okay, that's good. So now if I move my x and y, I can get my line here. So let's explore how the line works. So it looks pretty good so far. I can see a little strange effect, but generally it's doing quite well. Let's try it for larger slopes. What happens? Okay, now it's getting kind of weird. It's all, why is it doing that? Can you imagine why? It looks good this way, but then, so when we get a large slope, the line starts to break up into individual dots here. That's not good. And what's even worse, I'm going to show you. Let's try to get a line that's perfectly vertical. Whoa. Well, first of all, it pretty much just disappears. But if I can get it perfectly vertical, I can show you that it's not a very good thing. Damn it. It won't stop at perfect vertical. My keyboard skills aren't fast enough. Well, then screw you, thing. Let me just tell you that if it goes perfectly vertical, it crashes the program. We saw that before, right? If you remember. So first things first. Well, first of all, the reason why it crashes the program, I'm just going to show you guys how it crashes. So we'll draw our line from 400, 300 to 400, 400. It doesn't crash. That's right. Okay. Let's see why it doesn't crash. Let's see what happens when we draw a vertical line here. Gotta go to graphics. We gotta set our breakpoint. Do this again. Okay, so our dx is equal to 0, our dy is equal to 100. And now we're going to divide 100 by 0. And if you know something about math, you know that dividing by 0 generally doesn't give you a very useful result. And our result here is infinity. Right. Now the reason why our program crashed before was if you divide an integer by 0, you get an exception and your program will just puke. But if you divide a floating point value by 0, it actually works fine. You just get the result infinity. So now our slope is equal to infinity, which is, I guess it's kind of cool, but it doesn't change the fact that it's not going to give us a very useful result. Right? Now our y-intercept is equal to negative infinity, and we're just going to get shitty values here. Y is equal to what? What is our y? Tell us. Y is equal to negative 2 billion. Good luck drawing that pixel. on the screen. Alright, so basically when we have a perfectly vertical line, our program just craps out. And maybe sometimes it might even crash, or it might just not draw pixels very well. So that's one problem. Now the other problem where is it? There it is. Alright, put this back to X and Y. The other problem here is when we have a very large slope, our line just gets all broken up. And the reason for that is the following. Let me just get my thing up here. Yeah, you can die. No, I said die. There. Sure. Here we go. I don't like this layer. What about this layer? That's no good either. Let's make a new layer. There we go. So let's say we've got a, we're going to draw a line here. And here's our P1. And here's our P2. So here we have a large slope, right? Our rise is large compared to our run. And the problem is when we loop through our x's, x1 to x2, we're only drawing 3 pixels, right? We only run the body of the loop 3 times. So we can only put down 3 pixels to cover this entire length here. So we'll put one here, obviously, and we'll probably put one right around here-ish. I don't know. Or maybe here. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, it'll go right here. There. So we'll put 1 pixel here, 1 pixel here, and 1 pixel here, right? And that will give us, well, basically what we saw in the program, right? Kind of, instead of a one solid line, it'll be a dotted line. So the problem is that when the dy is greater than dx, we're not drawing enough pixels to cover the entire line. Now the solution to this problem is very simple, and that is when dy is greater than dx, instead of looping through our x values, we should loop through our y values and calculate our x for every y value and then put a pixel. And in that case, we will not get any gaps for large slopes. And when we have a line that's say like this, then we loop through our x values. So we have to change the way we loop depending on the values of dy and dx. Alright. So we got to go back to our draw line function here. So we're going to get an if statement. If dy is greater than dx, then we want to do some stuff. Else, we do our loop that we've been doing up until now. Like this. Now I'm not going to go into all of the math of it, but basically we can calculate a different m and b. So if we're looping through our y values, we can calculate a different m and b. So we want, in this case, we want something like x equals my plus b, because we want to solve for x. So we'll take this away from here. We'll put this over here. So this is specific only to the case for when we're looping through our x values. Now we need to calculate a different m and b for when we're looping through our y's. So this time we'll do run over rise. I'm not sure if we actually need to do this. There might be other ways, but it seems the most symmetric solution in my opinion. Now b will be equal to x1 minus m times y1, if I'm not mistaken. So it's just the converse of this one here. And now we're going to be looping through our y. So we want y is equal to y1, and as long as y is less than or equal to y2, y plus plus. And here we want x is equal to m times y plus b. And then we put our pixel again at xy, RG in blue. And this should work now. Okay. We just get a couple of warnings here because we're converting, but that's fine. Alright, now if we go... Ugh, it's still not working good. Why is that not working? This is interesting. So if we... in this area, it works fine. Right. But over here... not so good. What gives, bro? What's up with that? Well, I'm just gonna cut with the suspense. I'm just gonna show you guys what's wrong, why we're getting this this result here. Okay, so what I need to do is I need to set my y equal to 150. No. X is 450 and y is 100. So if we do this, then we should start off, yeah, like this. All right. So why is our program not working properly? Again, we resort to our trusty debugger. Okay, so let's step through this crap. dx 50, that sounds right. dy negative 200, that's right, because we're moving up by 200, right? And in the screen coordinates, higher values are lower, right? Values close to the top of the screen are lower than ones at the bottom. So moving up is moving in the negative direction. So dy is negative 200 and dx is 50. Negative 200, 50. So that gives us a line that's kind of like this. Let me just draw that on here. So saying that this is our screen coordinates now. We don't care about this. You go to hell. All right. Here's our P1, and here's our P2-ish, right? So our line should be like this. So negative 200, that's fine. Now, that's interesting. So here we're saying if dy is greater than dx, then we should loop through our y values. Otherwise, we loop through our x values. Now, in this case, it's very clear that we should be looping through our y values, because our slope in the y is much more, considerable than our x component of the slope, right? We're rising more than we're running. So what's the problem here? Can you see? The problem is that although our dy does have a larger magnitude than our dx, our dy is a negative number, right? It's moving in the negative direction, and dx is positive. So in fact, on the number line, right, on our number line, here we have 0. Here's our x of 50. That's x. And here, damn it, my tablet doesn't go that far. All right, number line, do your thing. Here we go. So here's our x of 50 on the number line, and here is 0, and way over here is our negative 200y. So yeah, y is less than x, right? Y is less than x. But the thing is we don't, when we're looking at the slope of the line, we don't really care about the direction. We just care about how steep it is. We only care about the magnitude of the dy and the dx. We don't care about its sign. So what we should be doing is, instead of checking whether dy is greater than dx, we should be checking whether the absolute value of dy is greater than the absolute value of dx. What's the absolute value, you ask? Well, let me tell you this. Explain it this way. The absolute value of negative 200 is equal to 200. And the absolute value of 200 is equal to 200. So the absolute value function in math just strips away the sign. If it's negative, it makes it positive. If it's positive, it leaves it alone. All right? So we need to do an absolute value on our dy and our dx. And we can do that. We could even write our own function to do that. But the C library gives us a handy function to do that. So let's use it. Now, in order to use the math functions from the C library, we have to include math.h. This is an include statement. It includes a header file into this file here, into this source file, and it allows us to use the functions which are declared in that header file. So in math.h, there's a bunch of functions that are declared, and one of those functions is the absolute value function, abs. No, this will not give you a six-pack, unfortunately. So what we want to do is we want to check whether the absolute value of dy is greater than the absolute value of dx. And if we do that, then we should get the correct response for every quadrant around our... What the hell? Alright, let me just... Okay, so we're doing x and y. I want to set my x and my y back to their normal values here, which was 500 and 300. Alright, so we're back here, and as usual, this one works fine. This quadrant here works fine. This one works fine too. And when we go up here, and we disappeared. We're good. We're good. We're good. We're not good. What happens if we go down this way? All right, we're good. We're good. We're good. We're good, and we're gone. Okay, so that made things worse. Actually, does that mean that we should not use the absolute? Not at all. We should definitely be using the absolute value here. But there is another problem with our code. And to find that problem, again, we will be relying on Mr. Debugger. Okay, so what's going wrong here? Tell me your story. Okay. Damn it. We can't debug it until we get into the Badlands, as it were. So we need to initialize our variables again to go into the bad place. So 450 and 100. Stop. I just want to make sure that this is the bad place. Okay, yeah, we're not getting anything here. So let's see why we're not getting anything. Okay, so dx is 50, right? Alright, so we got our P1 here at 400, 300. And we have our P2 here at 450, 100. And the damn program isn't drawing our line. So our dx here, dx is equal to 50, and dy is equal to negative 200. Or at least that's what they should be equal to. Let's check it out. dx 50, dy negative 200. So far so good. So now we check if the absolute value of dy is greater than the absolute value of dx. And apparently it is. And of course it is, because 200 is greater than 50. So now we calculate our m. What was our m? Negative 0.25. That seems about right, I guess. I don't know. Yeah, because this is now our run over our rise, right? We're calculating the inverse because we're moving along the y's. So yeah, that's correct. And we calculate our b. It's equal to 475. That seems like it could be right, I guess. I'll buy it. And now we're saying as long as y is equal to y1, and as long as y is less than or equal to y2, y plus plus. So y1 is equal to 400 and y2 is equal to 100. Right. So we just skipped through this whole loop. We never even entered it once. We just skipped it right to the end there. And the reason is because our starting y1, here, wait. Oh, you bastard. There. Our starting y here, y1, is greater than y2, right? This is p1. That's an r. p2. Our y1 here, 300, is greater than y2. So right at the beginning of the loop, we're already at our loop ending condition. Y is greater than y2, right? Because y is equal to y1. So we never even enter the loop once. It just automatically says, oh, we're finished. And that's it. But we're not finished, right? Because in this case, our y, our y1 and our y2 are out of order. We want to loop from here to here. We want to loop from 2 to 1 in this case. So when P2 is above P1 here, we want to loop from 2 to 1. But we're not doing that. So what we need to do here is at the beginning of the function, we need to say if y2 is, well, it doesn't matter. If y1 is greater than y2, int temporary is equal to y2. y2 is equal to y1. y1 is equal to temp. So what this does is it swaps the values of y2 and y1. But if we swap our y1 and our y2, we have to also swap our x1 and our x2 because they are a matching pair, right? So we have to also say that temp is equal to x2, x2 is equal to x1. No, that's stupid. Temp is equal to x2, x2 is equal to, no, it's okay. x1 is equal to temp. All right. Now if we do this, everything should be copacetic. Because now, if our y's are out of order, we swap our P1 and our P2. That's what we're doing here. We're swapping P1 and P2. So that will be looping in the correct direction. Now let's stop debugging and let's debug again. And now you can see our line, it appears where it should appear. Good. That's good. And now we can come down here. It's all coming into place. Beautiful. But it disappears over here. I think you can understand that it disappears because we did not do the swapping for this part too. The same problem appears here. So, I mean, obviously, if our, go to hell, if our P2 is here, and our P1 is here, generally normally P1 is on the left, P2 is on the right, and we loop through our x's this way. But if our P2 is actually on the left-hand side here, P2, we'll try to loop right, and we'll say, oh, we're already greater than P2, and we'll just give up. We'll never even try to draw the line. So in this case, we have to swap P2 and P1. So this is P1 then, and this becomes P2, and then we can loop from the left to the right. And we can just do that the same way we did with the other one. We just copy and paste here, except now we want to check for x1 and x2. This code can stay the same because it's just swapping them. Alright, now if we do this and we build, now we should be good to go for all quadrants here. Yeah, perfect. Alright. So now our line drawing function is really coming it's really coming to its own here. Alright, so our line drawing function is coming along very nicely. But there's still one little flaw left. I'm wondering if you guys can even see it here. I see it right now. It looks kind of funky. Yeah, that looks very funky. There's something wrong with the way the line is being drawn. It's creating a little graphical glitch, a little artifact here. What I want you guys to do is if possible, I want you to build write the program up until this point, up until here, and run it yourselves and see if you can spot the only flaw left in our algorithm here. Alright. So have you done that? Yeah, I didn't think so. Well, I'm going to tell you guys anyways. The problem is right here. Can you see it? It's like that very last pixel there on the bottom is it's got a little hook on it. It's got a little kink. And if I move right now the slope is negative. If I move the slope to a positive slope, then we see the kink has moved over to this side. Alright, so what is causing it? That's the question. Now I'm not going to go through the whole spiel of running the debugger and showing you guys exactly where the problem is. I'm just going to tell you. Remember what I told you before about floating point numbers and integers? So if you've got a number that's like float f is equal to, I don't know, 1.5. And then you say int x is equal to f. What happens is the compiler, so we have our f here, and we have x. And the compiler retrieves the value from f, which is a 1.5 floating point value. It then converts it to an integer, which basically cuts off the decimal part, just leaves it as a 1, and then it stores 1 into x. So the value in x will be 1. But as you know from your grade school math, if you're rounding the value of 1.5 to the nearest whole number, that would round up to 2, right? And the same thing as if I said float, now let's say float f is equal to 1.99, right? That's pretty damn, that's basically 2. But if you say x is equal to f, it's going to take that 1.99, it's going to convert it to an integer, which means it's going to chop off the decimal part, and you're going to get a 1. So that's a pretty big error, going from 1.99 rounding down to 1, right? That's almost half of what it should be. So the problem we have here in our program is when we're converting our, well here, for example, we'll go with y is equal to mx plus b. When we calculate m times x plus b, we got a floating point value here. And when we store it into y, we've got a integer. So we have to convert it. And when we convert it, we're just chopping off the decimal. And what we want to do is round the decimal. Now there's a few ways of going about rounding, handling the rounding off of floating point numbers. We are going to use this method here. We're going to add 0.5. The f just makes it a floating point number, a float. There are different floating point numbers that can hold more information. It's called a double, but we won't be using doubles, at least not now. I don't know if we ever will. So yeah, I gotta add here. I add 0.5 to this expression here. And what that will do is that will now allow me to round off. Let me show you how that works. Okay. So let's say I have a number 1.65. Now if I were to properly round that number, that would round to 2. But if we round using C++, or if we just convert from a float to an int, that will cut off this part and just give us 1. But if I first add 0.5 to that, 0.5, the value will now be 2.15. And when I convert that to an integer, now I get 2, which is the proper rounded value. Alright. Likewise, make this 1.45. Now if we round that to the nearest number, whole number, the value is 1. And if we add 0.5 to that, the result is 1.95. And converting that to an integer, chop off the decimal part and we just get a 1, which is the correct value, right? So by adding 0.5 before we convert, we can simulate the effect of rounding to the nearest whole number. Alright, I hope that makes sense to you guys. So, now, if I build this and start debugging, now my line should, the rounding should have been fixed and I shouldn't have that little kink at the end of the line. And it looks like the kink is gone. No more kinkiness for us. So this is our finished draw line function. Very nice.